Hi. First of all, I would like to say my trip from Randers in Denmark to here has been a living nightmare with SAS cancelling 1 of 2 flights and having to take a bus and a train to get to the plane to fly to Stockholm. So if this talk goes well and the demo goes well, I am more than ready for a hug. That's, yeah. And the organizer, they promised me to shut down the salad bar because I'm going to talk about some of the things that might not be fun to talk about. And you might disagree, which is more than fine, but we leave the salad bar out of this. I'm going to talk a bit about the history of where we are, because I want to try and tell you, or talk to you about, convey the why. Because it's actually really hard to describe the thing that I want to convey here. So I think I'll start with the why, then I'll talk about the strategy and show you how we can visualize strategy. And then I'm going to show you the projects we have started on how we make a platform that developers love. And then I'll try to give a demo as well. So my name is Henrik Høegh, worst international last name ever, but very Danish. I'm a product owner at Velux. Velux makes rooftop windows. So if you see a rooftop window, it's most likely a Velux window. I work in a team with a very modest name called CCOE, Cloud Center of Excellence. And in the team, we have a lot of great people. We have Jakob, Carlis, Linda, Evelina, Mehmet, Eva, and Katrina. And the best thing would be if they could present it, because they are the one who actually built this stuff. I just pushed the stone in the beginning. Yeah, you'll have to settle with me. So the agenda today, I'm going to talk about the why, and the way I'm going to do this is trying to talk about cognitive load over time, and how I've seen a battle between dev and ops over time, going back to Agile actually. Then I'm going to talk a bit about the big toolbox, which many people call platform engineering, which is probably a good name, but there's also a lot of problems with this new thing. And in order to build a platform that developers love, you need to actually go further than platform engineering. And you especially need empathy, but I'll leave that to the next speaker. I'll talk a bit about abstractions, how we try to abstract away this big toolbox and how we make something in front of it so that it's easy to use. And I'll give an example, and I'll also do a demo. And then I'll show the offerings that we have, and then I'll do the demo if the demo guards are with me today. The travel guards wasn't. So I've made this cognitive load graph that I totally did not trademark, but it is yet to be scientifically proven. So if we look over time for ops, first we have Agile. And what happened with Agile? Well, developers wanted to release all the time, and ops wasn't really ready for that. They were used to like 6 months intervals, right? So when developers came and said, we're doing sprints now, we need to release in 2 weeks, ops were like, but we haven't mounted the servers yet. So there was a lot of cognitive load on ops back then. And that actually drove, I think, a lot of the DevOps movement. And then DevOps helped ops by doing like configuration management and stuff like that, and infrastructure as code and so on. It became easier for ops. Then orchestration came in 2015 with Kubernetes released. There was a bit before that, but then it was actually quite hard to install Kubernetes. It was really hard. There was no installations, there was no distributions or anything. There was one repo called Kubernetes the Hard Way by Kelsey Hightower. That was where you learn how to install Kubernetes. It was really hard. And then came platform engineering, and this is where I think a lot of companies are now, and that's a lot easier because now you can automate it. I mean, everything is automated. You can get a distribution. So you can basically spin up 1,000 Kubernetes clusters if you want to, or 1 million. So the cognitive load is fairly low for ops right now, in my opinion. But if we flip it and look at developers, we can see that in Agile, things were actually quite easy for them. They had to learn how to stand up at least once a day and talk to each other, learn what a sprint is and stuff. It was manageable, right? And they got feedback faster. They could build better services and stuff like that. They were on fire. And then came DevOps and said, look, you only need to learn 2 things. It's super simple. Just need to learn Ansible and maybe Terraform. It's up your alley. You're developers, right? It's infrastructure as code. Yes, developers didn't like that. Then came orchestration. And from the developer's perspective, that was actually a step in the right direction, because then they had to learn YAML and indentation, basically, and make maybe 5 YAML files, right? In the beginning, it was super easy. But then platform engineering and everything matured, and then the Cambrian explosion happens, or the platform explosion happened, and we got like 1 million things that you need to make YAML for. You need to understand the entire platform. So the problem I see right now is that ops thinks it's super simple to create a Kubernetes cluster. So they're playing Oprah. You get a cluster, you get a cluster, everybody gets a cluster, right? And the problem is they automate this cluster and they give it to the developers and say, good luck. Oh, an ingress controller. Yeah, look it up. It's not in their domain. How many of you are developers and know what domain-driven design is? Couple, okay. So in domain-driven design, you have very specific boundaries. And if you cross boundaries, you have something called an anti-corruption layer. And that is to ensure that the language of one domain doesn't bleed into another domain. So in one domain, it might be a customer. In another, it might be a subscriber. Maybe Spotify can elaborate on this. But you know, you don't bleed into other domains. And what is it that we do? Ops bleed into the developers' domain. Developers want to write code and solve problems, not writing Terraform or Ansible or Puppet or Chef, or know what a replica set is, or replication controller, if you're that old. And they don't want to know what, like Kubernetes, what is that? Why is that even important? Why is that important to me as a developer? How does that solve my problem? I just want my app to run. That's all I want, right? I want to be able to release it. And there's something about the difference between being affected of something and having the responsibility of something. So I actually had a couple of people coming up to me and say their developers only need to learn Ansible and Terraform. And that's just really, really bad practice, in my opinion. It has nothing to do with being a developer. They should not have to learn that, right? So we need to be able to talk about language as well. And we actually had a meeting in Riga, our developing team, about language for our CLI, where they all met and talked about the language. Because there was actually, in the specifications we made, a lot of words that was from our domain. We needed to try and remove them or use names that was in the developer's domain, because those are our customers. And then being affected and responsibility. I mean, imagine if a server rack in AWS catches fire, you'll be affected, but it's not your responsibility. So some people say, if you abstract things away, what will the developers do when you hide things? Well, it's not their responsibility. It's the platform team's responsibility. They will be affected, yes. So what do you do, right, if a server rack caught fire in AWS? Well, you don't do anything. You wait and you trust AWS to fix the problem. That's the same thing we should do. So in my talk, I don't have any AI or... I'm sorry. I can say that I used special AI to superimpose the two, but it would probably be a lie. But I did draw it myself, so I don't know if I count as intelligence. But the the thing we can see from this is that this is a funny trend. Was that a revenge? Or here, or here, right? The problem right now, and this is what I want to talk about, is that currently we're trying to do platform engineering. We're making the same mistake again. We're making things easy for us, one of the parts, and extremely difficult for the other one. As you can see here from this totally made up graph, developers to cognitive load is extremely high. And we need to bring that down. So what can bring this down? How can we help this? In my opinion, this is developer experience, or DevX, or whatever you want to call it. I see platform engineering and DevX as two different things because of this. So you need to treat it as a product, as if you were at AWS or ours or whatever you call it, and have a website and maybe a CLI or something like that. Right? So the Cambrian explosion, or platform explosion, like I think Jin Hong also mentioned, it just exploded, the cloud native landscape. So we cannot give this to developers and say, look, this is your responsibility right now. It's just only getting worse. So the problem is we're building these toolboxes and putting a lot of great stuff in it, and we are super proud because we build it ourselves. There's a slight IKEA effect in it. And we put all this great stuff in it and we give it to developers. And then they need to know everything. And we need to get away with this. So how do we fix this? Because we need the toolbox, right? We need all these tools. So the way we want to go about it is to experiment. So the founder of Velux said that one experiment is better than 1,000 expert assumptions. So great, let's play. We want to build a small, thin API between the toolbox and our developers. Imagine if every time something went wrong in ours, you needed to know everything that happened behind the curtain, right? I mean, all of their languages, scripting and everything, you don't need that, right? You have an API, you have a AWS CLI or whatever they call it, and you have a console. That's your gateway to their system. We want to do the same. We want to build an API between the two. So how do we do that? So we want to have a strategy, and I might or might not have made this afterwards, but that's the easiest way to make a strategy at least. But I think it's a good way to convey a strategy at least. It's something called Whatley mapping by Simon Whatley. Does everybody know what a Whatley map is? Well, this is it. So now you all know. So on the y-axis, the further up you are, the more visible it is to the user. And you can see the user at the top. It's not to scale, just so you know. The further down you go, the more hidden it is to the developer. So power in the data center is really far away from the developers, right? And the x-axis is maturity, basically. So in the left area, it's something that someone accidentally made work on his laptop or her laptop, right? And the further to the right you go, the more a commodity it is, or a product, or custom built. So here you can see what we had before we began this journey. We had a user. We actually had more than one. We are proud. They depend on GitHub. This is where they store their code. This is where they edit a GitHub's repo and a Helm chart repo in order to release. This is one of the things we wanted to attack. GitHub then depends on Flux to be able to actually get that somewhere, to release something, right? So this is the reconciliation mechanism that we use. And it also depends on Artifactory in order to deliver Docker files from GitHub Actions and release artifacts. Both Flux and Artifactory depend on Kubernetes. Now in this circle, Kubernetes is the product, or the project, so to speak. Because underneath it, we have two instantiations or installations of it. We have Azure AKS, and we have our own custom-built Kubernetes clusters. We have factories. So I think it's like 17 factories where we have Kubernetes in each of them, and we have the cloud ones. And on-prem installation depends on VMware, and it depends on power. So simplified, but this is something that is kind of easy to read. So when we convey a strategy, what is it that we want to change? Well, first of all, we want to create a new portal, a developer portal. So we chose Backstage. We didn't choose one of the pre-built ones because we wanted it to fit our needs, basically, the best. So this is where developers, so you can see users will depend on it, can do self-service. They can create repositories with scaffolding code. They can have a service discovery and all that stuff. Then the portal depends on Flux, basically, to get information about releases in all the clusters we have. So instead of asking the clusters about what release is currently running, and if it is running, you can now ask Backstage. So that's what we do. That's one thing. The other thing is we made a CLI called Bora. Bora is a Latvian word for sail on a ship, the thing that moves you forward. And with the Kubernetes theme and all that, it's nice. Bora has some dependencies, so you can say the user is depending on Bora. Bora depends on the portal to get the release informations, and it depends on GitHub in order to get the code and so on. And then you could say it depends on Artifactory to actually release some of the release artifacts when you want to release a service. Then we create 2 other projects that will be built into Bora as the CLI, like extensions. So we have MakeIT and Tanto. MakeIT is a new approach to implementing CI/CD in a very different way. And I want to demo that later on. Tanto is a way to run your CI in a very, very new way. I'll also talk a bit more about that. So if we take these, so Bora depend on these, of course. We can visualize that we want to move this to the right. We want to mature this. This is our investment. And if this happens, and if this goes well, it means that GitHub will be slightly less visible, because now they don't need to go there to update a Helm chart or a GitHub repo. They can just use Bora. And then, of course, we want to mature our on-prem installation. That's not super relevant here, but just to show it. So this is how you can visualize strategy to upper management, or something like that. So Backstage, everybody in the team, more or less, has a project that they are owner of. So they have the responsibility, and they actually made this thing from scratch. So Jakob is maintainer of Backstage by Spotify. So this is the website, the portal, where they can go in and see the service repository or service catalog. We made our own plugin so that they can register GitHub runners from the UI, because you need to be a GitHub admin to register a GitHub runner, which is weird. So here they can do self-service. They don't need to poke us every time. So single pane of glass, service catalog, self-service, super important, and templating new services. So the next step for us is to work with developers and say, when you create a new microservice in C#, in this case, what would be the perfect starting point? So you don't need to start from scratch every time. And then they can go to Backstage, click new, and then they'll get that scaffold out of the box, which is really awesome. Then we have Bora, made, maintained, named, and iconized by Linda in the team. She made the logo and everything. So Bora is the main CLI. So if you look at AWS CLI or Azure AZ or AC, this is basically our version of that to our platform. So it'll automate release processes. So one command and you released a service to an environment. You can enable auto-release. So you can basically define in code in your repo that I want auto-release to dev. So when you merge to main, it'll just get directly to dev. You don't need to do anything. So no need to go into Git repos and so on. And you can get an easy status, like this service, which versions are running in the different clusters, right? How many of you can actually do that in Not many people do it. 1, awesome. 2, better. 3, stop it. I want to talk a bit about CI/CD. I love CI/CD. It's just I really think the implementation went bad. We started with a butler, then we got a new butler, then it got containerized, and that's basically it that happened in CI/CD systems, I think. So imagine a security check fails. Where in your pipeline do you have security checks? Is it in CI or CD? It's usually CD, right? CI should be fast, blah, blah, blah. Where in CD do you have your security step? Mostly in the end, right? So if it doesn't pass, what do you need to do as a developer? You need to clone the freaking thing again, try to fix it, push it, merge it to main, get through CI, and then at the end of the pipeline, you have to wait for the security thing to work again, to get your feedback. That's just not good enough. Why can't you do it on your laptop? So what we want to do is we want to rethink CI and how we implement it. So right now the problem is the only one who knows how to security check your code is this butler or whatever you use, because that logic is in that system, right? But what if we take that out and put it in another repository and call that a plan? So when you do your checks, whatever you need to run in CI, you would clone the repo first, the plan, and then run the step from there. Then what's keeping me from doing the same thing on my laptop? Everything CI can do, we can do on our laptops. That's the goal. The other thing is we learned that if you have this 14-step program, no, CI platform, no, template, our developers didn't want to use it. Why was that? Well, because it was all or nothing. They could either opt in or opt out on the entire thing. So what we did was we said, well, if you use a plan and you call a step in the plan, but you had that step locally in your repo, why not just run that one instead every time? It's a simple if statement. That means you can opt out on any step instead of the entire plan. No matter where you ran this, CI, laptop, wherever, it would always do the same thing. And you wouldn't have to do anything else. You type the exact same command. So what we end up with is we have one command in each step in CI. So this is MakeIT. It's quite hard to explain, but I think when you see it, it's quite simple. This is Carly's project. It's built into Bora. So we have these atomic actions, so build container, scan container, lint container, whatever, right? And these are scripts in a plan. We can run it anywhere you want. DigitalOcean, your mother's computer, wherever. You can opt out on a single step, and that's the whole idea. We don't want it to be a golden cage. Golden path, yeah. We want fast feedback. So when the security step fails, we want to run it locally on a laptop instantly and get the feedback super fast, right? So enable, empower our developers, not having them to wait. Then we have Tanto. So Tanto is basically an extension to MakeIT. So now we have all the atomic actions. So how do we create pipelines? Well, we have this recipe, so to speaking, where you say first you run this step, then you run this step, and then you run this step, and so on. What if you have to change something? Then you have to edit this file, right? What if I add a new step? I need to edit the file. What if we didn't need this static pipeline definition? And that's what we removed with Tanto. So we have dynamic pipeline configuration. So each step in the plan knows if it should run in CI or CD and in what step. And then it's just a matter of gathering the information and then do it, right? If you opt out on a step, you can change it to no, don't run in CI or run later or earlier, and then it'll just magically happen for that service. You can run it everywhere. So the only thing we need with Tanto, because Tanto uses Dagger underneath, the company or the people who made Docker made Dagger. So basically you can code in Go, for instance, your own CI system. So the only thing you need is something to ignite your CI system or this thing. That's all. So this means in Jenkins, you'll have one step called Bora run CI or something like that. That's it. Or in GitHub Action, and you can move it. You're not tied into Jenkins anymore or whatever you use. And it uses containers for everything. So every step is run in containers. So we don't need to install all the tools on our developer laptops anymore. Yes, so we containerize them. So what we end up with is a bit like when you go to AWS or Azure or GISP. You get a UI and you get a CLI. And with those two things, you can do everything you need to do. Right? So let's do a demo. I have roughly 10 minutes left. So if Wi-Fi is still enabled and the VPN is still active, then this should work. So there's a really good friend of mine called Kasper Hermansen who made a really nice script. And I totally stole that. So on my laptop, I can just say gclone. It'll list all our Git repos. I can search, is it open? Good. Then I'm ready to edit my code. So that's nice. So here we have a repo. In this repo is a bit special because there's two projects basically. So it's small mono repo, or two services in one. We have front end and an API end. Let's look at the front end. So we have a file called bora.yaml. And in this, we have all the information like the name of the service, who owns it, business owner, technical owner, oh, that's me, and so on. And everything the developer needs to define for the service is in this file. And then Bora can use it. So I can basically do Bora list. I need to go to source and then front end. And then I can do it because it reads the Bora file. You can also give it parameters instead, or you can have a configuration file. And if we just move this, you can see that we have these versions that I can release. So whenever a pipeline is done, it will upload release artifacts to Artifactory. And this command shows me exactly which versions I can release. So now I want to know what's actually running. So I'm going to go to Bora status. And this is still the old implementation where it actually asks every cluster. So that's why it's a bit slow. The new one will actually ask Backstage. So here you can see that in all clusters we have the same version, which namespace, and so on. So I can get an overview of my service instantly. I can also release, so I can just say Bora release version this to this environment, enter. Then a couple of minutes later, it's running. Because all the stuff about updating GitHub's repos and stuff is now something Bora does for you. It's not something you have to do. So let's look at MakeIT. So we try to reinvent CI. So we can do Bora make list. And in Bora, or in MakeIT, we have two concepts. This is a bit too big. Is it this? Yeah. We have workflows. So this is an action you can call, and then it'll do multiple actions behind the scene. So this is so that developers don't need to do all these things to get to this thing that they actually want every time. So here they can just do one command and then it'll run those. If you want all the actions, and the CI will always use the atomic actions, you can do -A for all. So now you can see these. So let's say I'm a developer. No, I'm not, but let's just say it. It would be irresponsible. So I can do Bora make build container. I need to build a container. Do I know how to build a container? No. Do I need to know? No. I can just run the command, and if Yes, so now it builds a container for me. So we abstracted away the reason or how a container is built in the plan. Let's security scan it, because there's a problem, right? So we can do scan container. So Bora make scan container. And now it'll actually use Sysdig CLI scanner to run a scan on the container I just built. And if I'm lucky, it will give me a result that is pleasing to all the DevSecOps people, or whatever they are. Yes, critical, 0, high, 0, and so on. And I get a link to the dashboard for this run, or this check in the code. So this way, everything that happens in CI, I can do on my laptop now. I can get instant feedback, trademark. I don't have to wait. And I know that back when CI was implemented, getting feedback within 15 minutes was super fast. But now it's actually not good enough. We want faster feedback. We want instant feedback. Yes. So now we have all these atomic actions that we can run. So this means that in your Jenkins pipeline, you could have Bora make this, Bora make this, Bora make this. But what if we could tell each step that, yes, you need to run in CI. Yes, you need to run in this order. So the way we chose to do that, and it's not perfect, but it's a beginning, is that if you go to the front end, you now have a .plan folder. This is the plan I was talking about. Bora automatically pulls that down for you. Under this, we have all the scripts for this plan. So you can see build container, for instance. And there's an environment variable called metadata. And here we have the steps, whether it should run or not, and in what order it should run. So we have 1 to 100. We take all the 10th, and then developers can actually extend plans and then fill in the gaps if they want to, or run them simultaneously. So what if so right now we have a small script just to get Tanto running, because Tanto is a very, very new project. So if we do Bora make order, we can see that we get a tanto.yaml file, and this is basically your Jenkins file or GitHub action file for us. So if you run Tanto with this file, it will run all these steps in a container. If they have the same sequence, it'll run them in parallel. So I can run the pipeline on my laptop. Okay, cool. So what about the golden cage? Oh, let's say that the build container step in the plan doesn't work for my service because my service is special or something. Then what you can do is you can do Bora make copy build container. So every step can be added with a copy in front of it. We might change that in the future, because if someone wants to make an atomic action called something with copy, then it goes wrong. So what it does is it goes to the plan, find the script, creates a new script folder in your repository, in your service repository, and copy the script to that folder. And Bora will always look in this folder first. So if you have anything there with the name, then it'll run that, not the plan script. So if I go to front end scripts folder here, so I can basically do something like echo hello and save. So if I do Bora make build container now on in CI or whatever, we get the custom one. So I opted out with one command, and I can do that for any step in the plan. How do I not opt out again? Well, I just remove the script. It's an if statement. It's almost machine learning. Yes. So this also has a small dilemma, because then someone clever, and that was not me, asked, what if developers opt out on the security step and say return true? And that was a good point. So we are starting a new project called Panko that will actually record everything that is done, especially in CI. So if you opt out, Bora knows it because it's the one that does it for you. And it'll actually flag whenever you opt out on something. That's the plan at least. So we can see if you opt out on these very critical steps, we might want to have a discussion with you why that's happening. Yes. The great thing about this is that if you go from one team to another team, you can just do Bora make list and see what can I do. It's the same workflow for each service. Because the plan is in its own repo, we can inherit it from multiple repositories, right? So every microservice can use the same plan, for instance, for C#. Yes. Cool. That went well. That was actually my talk. I hope that I managed to tell how we are working with DevX, how we're going to get the cognitive load down for our developers so they don't need to know all these things. In the future, I hope that in your bora.yaml file, you can say db true type Postgres size something. Then you just get a database or a Kafka connector or whatever you need, right? But it's important to really think about the language you use when you do these things. So one of the things we are changing is it's not going to be Bora make build container because developers don't need to know what MakeIT is. It should be something like Bora run build container, whatever. Right? So linguistics. That's a hard word. Yes, that was my talk. Thank you so much for listening.